So here are a couple of examples of timing diagrams. Now, timing diagrams are not more complicated than the examples that we just finished. They're a lot more compressed. They're a lot more compact. And so we're going to be able to see that there are lots of the same sorts of decisions that we were making in the previous example. It's just that they're all going to be on one figure. So here we can see a timing diagram where the clock signal already shows these arrows, and those arrows are indicating that this is an active falling edge clock signal. The dotted lines are already drawn for us, so that's a nice shortcut. All I need to do then is I need to identify what is the value of J and what is the value of K at each active clock edge, and then figure out what function is going to be performed, and then perform that function on Q. So here I can see that J contains 0 and K contains 1 at the first active clock edge. Well, that's a reset. And so I'm going to write a little lowercase or a little capital R right underneath here. Now, because the J and the K are predetermined for me, I can go ahead and do all of this before I do any calculations on Q. So I'm going to go ahead and do that. So here J equals 1, K equals 0, that's a set. J equals 1, K equals 1, that's a toggle. J equals 0, K equals 0, that's a hold. J equals 0, K equals 1, that's a reset. J equals 1, K equals 0, that's a set. And then J equals 0, K equals 1, that's a reset. Okay, now I need to figure out what does that actually mean as Q is moving along. You can see that this first little bit of Q is shown here. That's to help us to see where does Q start, because maybe this first one would either be a hold or a toggle, and if that's the case, then we would need to know what the initial value was. But in this case, that didn't happen. We know that it's going to reset, which means that really it's just going to stay continuing on with the same value that it had. Then when we get to this set, now it's going to go up to a 1. It's going to stay at 1 until the next active clock edge. When it gets to a toggle, toggle says go to the opposite. So I'm going to go to the opposite. I get to here, it says hold. That means stay with what you used to have. R stands for reset, means go to 0. We were already at 0, so we're going to go ahead and stay at 0. S means to set, so I'm going to go up to 1. And then I'm going to go on to the next active clock edge. I get a reset. Reset means go to 0. And I'm going to stay at 0 until the end of the time. So you can see that it's really a three-step process. Identify the values of J and K, identify which function is being performed, and then perform that function on Q. Let's see another example. Here we know that this is the flip-flop has an active rising edge. That's not shown on the circuit, or it's not shown on the figure, but it is told to us in the problem statement. So I'm going to go ahead and add the little arrows here to indicate the active rising edge. And then also, just because it makes it a little bit easier for me, I'm going to go ahead and add the dotted lines here to be able to see where the activity is going to take place. Because where the activity takes place, that's where I need to perform my three-step process. Okay, now with a ruler, you could make this look a lot nicer, but I don't have a ruler here, so I'm just going to go ahead and do it the way that I've got it. So again, now the problem really has been reduced to what we just did. I'm going to identify that J equals 0, K equals 1. That's a reset. I'll go ahead and follow through on Q here. Oh, Q starts out at 1 in this case, so it needs to transition down to a 0. It'll go to 0 and it'll stay there until the next active clock edge. And this active clock edge, I see that J equals 1 and K equals 0, so that's going to be a set. So there's a set. This was a reset. And then so set goes up, and it goes there until the next active clock edge. This contains a 1, and here's a 1. That's a toggle. So I'm going to go ahead and toggle down. I'm going to go on to the next active edge. This is a 0, and this is a 0. Both are zeros. That's a hold. So stay with the value that we had. A 1. A 1 and a 1, that's going to give me a toggle. So I go to the opposite value. I have a 0 here and a 0, so that's going to be a hold. So stay with the value that I had. And then a 1 and a 0, that's going to be a set. Set means go to 1, but I'm already at 1, so I'm just going to stay at 1. So if you get a problem like this on a quiz or an exam, it's very straightforward to just work your way through, and at each step, figure out the value of J and K, figure out what function is being performed, and then figure out what the new value of Q should be.